All right, hey guys, we're doing density of fluids, and the definition of density is the measure of how much volume or how much mass is contained in a given volume of substance. So, density of water is equal to about 1 gram per milliliter. Okay. The density of syrup is
1.37.
about 1.37 grams per milliliter, and the density of oil is about 0.92 grams per milliliter. Just zoom in.
And how you find density is the equation is right on the top right. It's mass over volume. Okay.
Yeah, so we'll be doing an experiment involving a cup. So in this cup, we'll be combining all three liquids, and to find out where each one would be in the cup is based on the density. So for example, we have 3 liquids, so it'll be 1 here, 2 here, and then the top. And the way to find out which liquid will be where is by determining the density. So as you can see, the density of syrup is the greatest number out of all 3. So meaning it will be falling in the bottom of the cup. Syrup, and then in the following number would be the density of water, which is 1, and the density of oil, which is 0.92. So based on the densities, we're making an assumption that within the experiment of the cup, we think the syrup will be falling in the bottom, water in the middle, and oil on top.
All right, so next we're going to be talking about some of the materials we're going to be dropping into our liquid mix. So the first one is going to be a metal washer. Yeah, you have to get that. And a metal washer has a density of about 7.8 grams per milliliter. And then our next one's going to be a grape tomato.
Yeah, no, this is like final.
I should take it off, right? That's what I was telling you.
And a grape tomato has a density of like 0.98 grams per milliliter. And then our final one is going to be a bottle cap, a plastic bottle cap, which has, what was the density? 0.6 grams per milliliter.
So based on these numbers, we can also make a hypothesis, just like the last section of our video. So based on the washer, we can hypothesize that the washer is going to land with the syrup. Based on the numbers, we can also hypothesize that the tomato is going to land within the water. And then for our bottle cap, it will be set at the top with the oil.
Hey guys.
I'm Anthony.
I'm Anthony Phillips.
I'm Gael Morales.
And I'm Dylan Ortiz filming, and we're explaining density of fluids and how there's 3 different types of fluids, and we have 3 different types of objects. So.
All right, so first we're going to pour in the syrup, which would be the densest of all 3. So we're going to pour to like 1/3 of the cup.
That's good.
Next, we're going to pour the water, which is the second densest. I'm going to pour another 1/3.
Oh, it's good, it's good.
Oh, chill.
All right.
And then last, we're doing the vegetable oil. So it should be going on top. It's the less dense.
Let it settle. There we go.
Yeah, so you can clearly see the separation between the layers, as the oil is the least dense and then the syrup is the most dense, and you can see how the water sits right in between them, which is a great thing. And then we're going to put these 3 objects in. We're going to start with the washer to see where the washer lands in the 3.
It should sink all the way to the bottom. Perfect.
Yeah, so it's sitting right on the bottom.
I don't know if you can see it. Yeah. It's down there.
And then we're going to do the grape tomato.
Yeah, this should be in the water.
Perfect.
Yeah, so it sits right on top of the water below the oil.
It's less dense than the syrup, so
When
Yeah.
you got the bottle cap, it should be landing on top.
Yeah, and the bottle cap is the least dense, so it stays on top.
perfect.
So that's good.
2 minutes. We have 2 minutes.
It was only 2 minutes.
Oh, that shit's good.